Bismillahirrahmanirrahim. In this session, we will discuss the symmetry properties of shapes and solids. And for this purpose, we have chosen exercise 31.3 from Hodder's Education for O-level book of mathematics. And from there, we have this first question: describe the symmetry of each of these shapes: a rectangular shape, an equilateral triangle, or a regular pentagon. So let's start this. The symmetry of properties of shapes and solids. So in this first question, a rectangle has two symmetries. Lines of symmetries are two, because if we have this line of symmetry, we can fold it exactly, it appears, and if we have this lines, then we have this folded on it. So this two lines of symmetries exist in a rectangle, and the rotation of symmetry is 2. If we rotate it 180 degree, then it gives a similar shape. So this has two rotational symmetry order, and lines of symmetries are also 2. It can be seen if we rotate it 90 degree, then it becomes like this, and if we rotate again, then it will appear again in this shape. So 90 degree it will appear like this. After more once again 90 degree, it will appear like this. So at 180 degree shift, it will have a similar shape like this. So after 360, it will have same shape. So it has two order of symmetry. Rotational symmetry order is 2. An equilateral triangle, here we have 3 lines of symmetry, because every angle and every side are equal. So this line of symmetry and this line of symmetry and this line of symmetry are the lines of symmetries. And the rotational symmetry 120 degree. After 120 degree rotation, this point will appear here, and this will here, and this will here. So similarly, after second rotation, this line will appear here, and after that. So there are 3 lines of rotational order symmetries for this equilateral triangle. For this pentagon, we have these 5 lines of symmetries, and for rotational symmetry, the order is 5. This is also very important. So that's the next question. Write down the number of the planes of the symmetries of each of these solids, cubes, or a cone. For a cube, we have this shape, and the number of plane symmetries is 9, because if we from every sides, it has a plane. So there are 9 planes exist, and the number of symmetries of plane symmetries are 9 in this cube shape. And for cone shape, the number of plane symmetries are infinite, because at every point, if we rotate, it will again be the cone. So for infinite number of symmetries exist in this cone. So if we rotate it, so it will give plane symmetries in infinite terms. So question number 3, describe the symmetry of a prism which has an isosceles triangle for its cross section. So this is an isosceles triangle. Here this side and this sides are equal, while this side is different. So these angles are equals. So these angles are equal. So if we bisect this angle or bisect this angle, we have this 2 planes of symmetries. And this lines, if we place this line, then this is called an axis of symmetries. One axis symmetry and 2 plane symmetries exist here. For question number, let's solve question number 6. A solid with infinite number of plane symmetries and infinite number of axes of symmetries for a sphere. So, it has been asked that a solid shape, which solid has an infinite number of planes of symmetry, and infinite number of axes of symmetry. That is only a sphere. can be seen from here. This is a plane sphere. Now we are going to solve exercise 31.4, and in this session we have AT and BT are triangles to the circle center O. What is the mathematical name of the quadrilateral OATB? OATB. So we have to name it. If this is a tangent, AT is a tangent, and BT is also a tangent on this circle, and this is a radius, and this is also a radius. So this line and this length is equal, and this length and this length is also equal. So this side is equal, this side and this side is equal. So this is nothing but a shape of a kite. So let's solve it. So here we have this AT is equal to tangent to the circle, BT is also a tangent to the circle, O is the radius, and OB is the radius, OT is the line of symmetry, this is the line of symmetry. So and the bisect AOB, this is AOB, and this basically this line symmetry bisect this angle AOT, and AOT is equal to BOT. AOT, this angle from here to here, from here to here, and this angle from here to here are equals, and OT is common to the triangle OAT. OT is common to the triangle OAT. This line and this lines are equal, and this line is equal. So these two symmetry triangles AOT and BOT are equals. So these are the lines of the triangle OAT and BTs are congruent. This congruent triangle has one line of symmetry and no rotational symmetry. So therefore this shape is a kite. So these are some of the reasons that suggest that this is a kite. Let's solve this. Question number 3. A, B, C are the points on a circle center O. M is the midpoint of BC. This is M is the midpoint of this line, and this is an equilateral triangle. ABC are the circle center O. M is the midpoint of BC. CAM. This angle is 28 degree. Work out MCA. MCA. We have to find this angle. Give reasons for your answer. So this is the M is the midpoint. So this is M is the midpoint, and BC is on BC. This M is the midpoint on BC, and CAM is given as 28 degree. Work out MCA. So we have to MCA. We have to find this angle. So BC is a chord to the circle. This is a chord to the circle center O. And M is the midpoint of BC. M is the midpoint of BC, OB and OC. This OB is a radius, and OC is also a radius. This OC is also a radius. So OBC is isosceles. OBNC, this triangle is basically an isosceles because this length and this length is a radius. This is radius, this is radius, and this is a chord. OM is a line of symmetry for OBM. OM is a line of symmetry for these two triangles. So OM is perpendicular to the chord BC. So this OM is perpendicular to this chord BC. So AMC, this angle is 90 degrees. If it is perpendicular, this is 90 degrees. This is 28 degree. So the remaining is 180 minus 90 minus 28, and this is given as 90 minus 28 because this is 90. So this is 90 minus 28. So this gives us 62 degrees. So this MCA is 62 degrees. So that's all from this, and in the next session we will take another chapter.